So what we're going to look at is how to make a dilution. So what we've got here is 1 mole per litre hydrochloric acid. It's about 10 times too concentrated to react with our standard solution. Our standard solution is about 0.1 moles per litre, so 10 times less than this. So I need to dilute this so it's 10 times less, or about 0.1, to see if it really is 1 mole per litre or not. So what I've done is I've got myself a beaker and I've rinsed it with hydrochloric acid and then tipped that down the sink. I rinse this with what I'm going to put in it because it's really important I don't change the concentration. If I rinse it with water and then put the hydrochloric acid in, I've automatically diluted that without meaning to. So I've put a little bit in this, I'm sorry I did this at lunchtime, not now, a little bit of hydrochloric acid in, swirled it across the walls of it as I tip it out. And then what I've done is I've filled it up to beyond where I need to go with it. I've now got some other equipment that I'm going to use to transfer it. In year 12 and previous, to make a dilution, you would have used a measuring cylinder to make this dilution, but that's not precise enough. Measuring cylinders can be even, let's say it was a 10 mil measuring cylinder, they can be inaccurate up to about 10%. They can be out by a lot. So we want to, sorry, about 1%. So we want to be careful on that. They can be out by quite a lot. So instead what we're going to use is a thing called a pipette or a pipette. I don't care what you call it. Okay, it's semantics, it's pronunciation. This is 20 mils, and to that line there, it is exactly 20 mils, so long as it says there, it says EX 20 degrees Celsius, so long as it's not too much hotter than 20 degrees Celsius or colder than 20 degrees Celsius. And it's about that. Okay, the labs are generally kept at about 20. So if you've asked why it was 20 degrees, that's why. It makes our equipment more correct. We've got a volumetric flask again with its lid, and that's been cleaned out with distilled water. So distilled water, the hydrochloric acid. Now I haven't cleaned this one out yet. The concentration of what goes in here is really important. So I have to clean it out with my hydrochloric acid. So I've got a pipette or pipette filler, and I'm going to put this onto here. And there's a couple of things for health and safety we need to be aware of. We don't do this because it could snap and go through our hand either way. And I have actually seen that happen at university, where it's gone in and out someone's hand. So we go very close together. Those who love their physics, this is so that we limit the amount of torque we're putting on it. We're not going to create a moment that could lead to breaking and going through our hand. So we simply push and twist, okay, until it's on relatively well. Then what we do is, this thing here can make it take at least 25 mils. It says that somewhere on it. We're going to draw up just a little bit of our hydrochloric acid. We're not going to let it touch the bottom of the glass. We don't need much. Now, this is where I should do it over a lab station, but that's not so helpful for videoing. So then what we do is, I'm going to tip it so that I'm not going to have anything dripping out. I'm going to carefully take this off and tip it up the other way, and I'm going to release my thumb. It goes real slowly until it gets to the bulb, because the bulb is where the most of it being dirty might be. I go past my line here so that I've got plenty of that being dissolved, and then I tip it out down the sink. Fun. Now this will leave a very small amount of solution in the very end of it. That's fine. For the effect that will have on the concentration of what we're putting in there, so our third significant figure, that doesn't matter. So we leave it in there. Then what I'm going to do is, again very carefully, put it back on, and I'm going to draw it up until it goes past this line. Now go past for a reason. And what I'm doing is I'm rolling this to get it to pull it up. Hoping that I'll put enough in. When it goes past the bulb, go very slowly, because it will it'll shoot up into the pipette filler, and that's not so good. Then here's the hard bit. We have to take it off and get our thumb on there as fast as we can. Then it's all about technique now, is we roll our thumb and keep our eye level with the line until that meniscus, I haven't done this in a couple of years, so this will be interesting to see how good my technique is. There we go, till the bottom of the meniscus is on the line. Then, this has been rinsed with distilled water, remember? I'm going to put that in here. So what I've got is I've got a 20ml pipette and I've got a 200, not 250 ml volumetric flask. And then I just have to be patient. So we don't get this and then force it out. We just have to be patient and let it trickle down. And there we go. Then what we do is we touch it to the edge of the glass and take it away. There will be a little bit left in there. That is meant to be there. That is part of the calibration of this piece of equipment. There should be a little bit left. If you force that out, it's not going to be 20.0 mils, it'll be a little bit more. Right, so we leave that. Then what we're going to do is, just like in our previous solution, this is now our secondary standard, by the way, or the thing we're going to find out, we are going to fill it up to just below the line. Because it's just a liquid that we're making the solution out of, we don't need to make it in a beaker first. Okay, we can make it straight in here. So, because this is going to be a really boring video to watch if I do the whole way, we're going to fill it up just below the line, put the lid on, rotate it 3 times, take the lid off again, let it settle, because there'll be a few drops up here we want to come down, and then we can, with our dropper, we can make it up so it's exactly on that 200ml line. Okay, and this is the chemical we're going to use, the diluted version of this, that we're going to try and see if it is actually 1 mol per litre or if that's lies and it was made just a bit simply and actually it's 1.05, for example, because we're going to be good to 3 significant figures. Right, so that's how we do a dilution of a solution. For you, it's probably going to be apple juice or orange juice or something like that, and you're going to have to work out what concentration you need and filter out all the solid first, then make your dilution.